Hello, we are Sunday, February 9th. It's been a bit since I last recorded this week. I didn't do too much. But today I wanted to do some Codeforces just to keep my brain sharp. And I'm going to try and do this contest, which is I guess it's not as bad, 6:30 a.m. It used to be 5:30 or 4:30. Was it because of the time change? I'm not sure. But anyways, it's quite early, so I'm gonna try to start adjusting my sleep schedule. Today we're gonna do virtual contest, and let's see, what time is it? Okay, I guess 10:40 is fine. And let me make the directory. So 996. And hopefully we're gonna do ABC. Oh my god, I freaking hate this. I thought this was nice, but the thing is, like, now when I reverse, okay, I don't know when it happens. It's like really annoying. Anyways, it doesn't happen right now, so we're fine. Okay, so yeah, we're gonna try to do ABC. So 996 A, and then B. Okay, we'll open A right now. And yeah, I've been doing Codeforces on and off. I had a goal of like reaching expert. Kind of hard stuck at. Yeah, I'm not really good, guys. You just gotta keep going. I've already solved 600. But just focus on the process, right? Focus on improving and then analyzing why you're slow, and then work on that. Okay, so let's start. There are n lily pads arranged in a row. Number from 1 to n. Alice, Bob, Frog. And she position on distinct lily pads A and B. They take turns jumping, starting from Alice. During a frog jump, it can jump either one space to the left or one space to the right, as long as the destination of pad exists. For example, she can either jump from zones, provide much jumps, and cannot remain on the scene. How the two pads cannot. This music. This is all determined. So who jumps first? Okay, Alice jumps first, and then so you're given N, A, and B. So in the first case, Alice tries to jump, but she cannot. So let's look at. So it's like you look at parity, I think, and then if the distance between Alice and Bob is odd, that means that Alice can jump. And then, so how is this gonna happen? So, Alice is going to be. Alice might be to the right of Bob, or might be to the left. So, one of them is gonna try to. This is really simple. I mean, you can DP it, you can search it, and then sort of like brute force it. That's too much work. Alice is gonna greenly try. If the distance is currently odd. Yeah, if their distance is currently odd, then Alice is going to get closer, and then if Bob will try to. If it's odd, Alice moves closer, so now it's even. And then if he gets closer and then gets closer, then Alice is gonna win. So Bob is gonna try to get away. So if the distance is odd, then Alice has won, because Alice can get closer. If Bob moves closer, then they get closer, and Alice gets closer. So Alice gets closer. Now it's even. If it's even, and like odd, odd, even that doesn't work for Bob, so Bob might go away. But then Alice will just chase. In the case that it's, so it becomes like even, odd, even, odd, even, odd, even, odd, right? So no matter what, every time he moves, let's just check the distance between the two, I think. And then if it's even, Alice will try to, if it's odd, it gets closer, even, yeah. It's just the distance between the two. Yes. Oh, did I flip it? Wait. Has a winning strategy. If it's odd, then Alice can become. Really? Wait. Alice, wait. Oh. Okay, it must be odd. I got it flipped. No, yes, no, yes. Alright. Okay, and now we need B. There are n different types of magic materials numbered from 1 to n. You have AI units of material from each I from 1 to n, and then they're allowed to perform these operations. Select the material, then spend 1 unit of every other material to gain 1 unit of material I, and then you increment the current material and decrement everything else. Note that all energy must remain non-negative, i.e. you cannot spend resources you not have. You're trying to you must have at least BI units including 0. Okay, this is not too complicated. So if you can iterate, okay, we got it. Okay, phew, we got it. Okay, so for this one, for B, what we need to do is we might have it in X. So in this example, 05511440. So that's how much we have. So we need to increment by 1, which means everything else need to be decremented. So doesn't matter. Can you just like try to increment and then decrement everything first? So if let's say it's 0550 and it's like 1441, if there are 2 materials that are under, then 0 needs to decrement everything, and then this one needs to decrement this. So these two are going to cancel each other out, right? So you can only have at most 1 item that's under less than the others, because if you have 2 less than the others, you need to decrement everything. You need to decrement everything to increase this one, but then this one is already behind, so you need to like increase this one, and then this gets decremented, so everything cancels out. So you can have only at most 1 thing that gets decremented. And then if you have 1 less, then you check the distance, and then make sure everything's within that bounds. int total less int end int a end sim n and bn for int I. And then I less than else for, and then you'll check so for the ones that are greater than bi, if ai minus this is less than bi, works equals false and break. Oh. Alright, so you have at most one item, and then that this is gonna be, it might be 0 or it might be 1, and then you decrement for all of those. You decrement it, and then if after decrementing it, it's under, then it doesn't work. Yes, no, yes. Okay, this one, if my logic is correct, if I misunderstood the question, I might have gotten it wrong. In which case, I would blame it because I'm rusty. Oh, we got it. Let's go. All right. The third one. In the wilderness lies a region of mountainous terrain represented as a rectangular grid with n rows and m columns. Each cell in the grid is defined by its position ij, where I is the row index and j is the column index. The altitude of cell ij. Oh, by the way, I shouldn't practice like this. There's a website called ThemeCP that I use, which is really good. Oh. Okay, let's log in again. So this one, you can see my profile, and like I've been practicing, and I'm slowly getting better with the mixed ones. And you can see my contest and like how I've been practicing. So yeah, okay. All right, back to the problem. In a region lies a mountainous terrain represented as a rectangular grid with n rows and n columns. Each cell in the grid is identified by its position ij, where I is the row index and j is the column index. The altitude is aij. A path consisting of n plus m minus 1 starting from here ending at here has been declared, so it's 1 2 so if it's n, so it's n minus 1 plus m minus 1. Right, m minus 1. Oh, I guess it's n cells and then n minus 1 cells. Okay, n plus n minus 1 cells have been cleared for each cell ij along this path. The altitude has been set to 0. The path moves strictly downward or rightward, so down or right. Okay, to restore the terrain, it's known that a region, all rows share the same sum of altitudes. Okay, the sum of all rows and all rows and all columns share the same sum. So we don't know what the path is, but we know. Wait, are we given? Like you know it's 0. Okay, so you know where the path is, right? and there only exists one path. So first of all, you got to figure out what that path is. It could be like it could be all zeros, right? Which could be a problem. Like you don't like 0 from the bottom. Like here, it's like very obvious that that's only one path, and all these examples are kind of trivial. Oh, they give us the path. Then isn't it easy? Like you know like, huh? And you must recover. So you know the path, and you know the sum of all elements except one. So you can sum it row-wise and column-wise, and then they should all be equal. But the cell values might be different, so you should take. I mean, you can just make a sum to 0, no? But oh, it must satisfy this number. Okay. Is that like a row? What's the largest 10, 1000, 10 to 9. Okay. Why don't we just make it sum to 0 then? Because it's 10 to the 6 times 1000, which is 10 to the 9, and then if you have, just make it sum to 0. Like this would be 1. Oh, because that might not necessarily work. Because you try to sum up to 0, row and column both. Huh. The thing is, we have what? It's like x plus something equals something plus y. So you have one equation, two unknowns. But you actually have more than, like, how many equations do we have? One, for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 unknowns, but we have 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. So we actually have enough. Okay, let me write it down. For this one, like, let's do an example. Call these like x1. Oh, and you can set all of them equal. like this is just linear algebra, but like you can solve it definitely. How do you solve this programmatically? Because you have x5, 4 plus x5. I guess like the bottom you could have solved it first, or the first x1, and then I think the top corners you can always solve them first then, no? So you know, like this number plus x1 is equal to this number, like not necessarily like you might have, like if it goes it's not as straightforward. Like like is the problem constrained? I think because you have n plus m equations and you have, how is it possible to have multiple solutions? And so you have it's not linearly independent. Is it always not linearly independent? Is it always linearly dependent? Like if you fix some value. like what if you just set it to 0 and then have everything else sum to that value? And then like that corner can just like be any value at the very end, right? So if you know what the top left value is, say here, if you just say this is 0, then this must sum to whatever, so you have whatever value. This must sum to whatever, this must sum to that target, then this must sum to that target, and we're fine. And then this must sum to that, this is, but at the very end, the 0, it might like not work, right? So that's why it doesn't work. What you really need to do is like solve that. This one's definitely close. So one observation is for each of these variables, you only need like the target. You can always, you already know like target in terms of x1, right? Target is equal to x1 plus, like I call x1 the first 0, then x2, then x3. Target is, in this case, target is equal to x1 plus 6. And then you know target is equal to x2 plus 0. Right? So you know everything in terms of target equals x n plus minus 1, okay? And once you have that, so you have like all these equations. You have n equations, n plus 1 unknowns. You can't just set the target, like, because there's an additional constraint, right? Like, if you set target to be 0, then yes, you set x1, x2, whatever, you know those values. But there's a further constraint. And that constraint is whatever, when it goes down or goes horizontally, right? Those are the constraints. Which is, so there's two extra equations here. So in this case, it's x1 plus x2 plus whatever, plus minus 1 is equal to target. And you have x, whatever, n plus x and minus 1 plus n minus 2 plus 3 equals target. And that's how you get like your n plus 1 unknowns, where you have n plus 2 equations. So we're good so far. But now the problem is that we have, how do we do this? Since you can rewrite it in terms of target, can you not subtract? Right, so in this case, we actually have x2 minus 6 minus 1 equals 0. So x2 minus 7 equals 0. So x2 equals 7. Right? If you have like all of them, So in this example, how we do this? So we have x1 plus x2 plus x3 plus x4 plus x5 equals target, and then you know like x1 plus something equals target, x2 plus something equals. So if you want to subtract all of them, you would do like, this is minus target, like you get to like x5, the last variable, equals target minus 4 target minus the sums x1 plus x2 plus x3, and then you solve for x4. In the case that there are multiple solutions, would this still work? 0, 0, 0, 0, 0, 1. You would know x1, x2. I guess the only one you don't know, there's only like one, there are two nodes you cannot write in terms of whatever, right? So in our case, in this case, it's x5. So the places where it's a corner is what you want to solve first. And you can solve those first. So you can solve x2 first in my iPad, and that's equal x2 plus equals target, and you know that x1 is 1 equals target, and then you can do equals x2 equals 1. Okay. And more specifically, I guess it's like minus, so it's actually target, the corner, x corner is equal to target minus number of before switch. But is that true? Like, what if it was a staircase? That's also possible. If it was a staircase, there's always corners, no? Like, so you know this one, you don't know this one, you don't know this one, you don't know this one, you know this one. In a staircase, you would, you know, you can solve for it, you can like break it down into a sub problem, right? Can you not? So it's like x1 plus equals target, x1, x2, there's x3, and you don't know how to write x3 plus, like x2 and x3 are both. Like, it's not trivial. Well, in this case, like, you have this equals this, so you can solve for x2. You can write x1 Negative x2. And oh, you can do it in O of it. You can do it in O of nm. Well, I guess that's 10 to the 6. You can do O of like n. You can do O of n squared, but like you have to go through everything basically. Aren't there like there's 2n equations though? There's the n plus m different equations. So I guess like what you do is like if it goes down, you solve for this and this, so you can solve for x2. If it goes to the right, it might do this, it might. Let me keep going down. I guess you can solve it until a corner. Until the first corner, the first corner appears. And then before the first corner, you can solve for everything before that first corner. This one. Alright. Okay, I think I got the idea, and now let's try to implement it. This one's going to be a bit difficult. Do this. So we're going to do row and then call. So this is curve pause. Okay. So we're if we're like stepping in the same direction, we're gonna continue. Else we're going to do calculations and store values, and then we're gonna call these x vector and x, and then the x I guess int x is equal to, so the path is going to be n plus m minus 1, right? 0, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5. Yeah. There's only 5 elements. So you might go down and then you might go right. And then do calculations and store values. If now we're gonna update new direction, and then we need to store like from which position do we not know, and then we should also get this suffix, get like a prefix sum, else it's gonna be, although it's like not too bad actually. So you're going down and it's telling you to switch directions. So then when you do that, you solve for the current position. So actually what we can do is just do this. If dir string I is equal to, we can just continue, else do calculations and store value. And then so this is x, so this row, right, from the last row. So every time we move a corner, we're gonna solve for the corner. So we're going to go from each row, calculate the sum, and then so sum is equal to 0. So how much time do I have left? Okay, now, okay. Sum, so it's gonna be the sum is gonna be, right, so each of these rows plus the sums. X plus 2 plus, and at this corner, well, at a corner where now we're trying to go right, so we're gonna sum until curve pause. We're gonna, and then this is like x1 plus x2 plus x3 x4 gibberish. Yeah, and then num rows a last curve pause the first minus last pause. Right, so the current row minus whatever row. So we go down what, 0, 1, 2, there are 2 num rows, and then we're gonna do a at curve pause dot first, curve pause dot second equals, oh, we don't know target. How do I oversee? I thought, oh wait, how did I? Right, oh wait, I think I had it, right? So x2 plus x3 plus x4 plus minus gibberish sum x1, you know, x1 plus x3 plus x4 plus x1 plus x2 plus minus sum 3 equals 0. can you like do something about this? Excellent. Oh my god, I thought I had it. Guys, how do I do this? Because when you have these corners, let's say it's like 3 and then this and then like you can eliminate this, but you have 3 and you want to break it down to 1. Dude. Why can't I do this C, man? It's okay. Trust the process. Trust the process. Huh, it's not working. I don't know, guys. Thought I had something. I don't know what I was thinking. Can you solve it? There's 3 equations, 2 unknowns. Like, you can't possibly solve it. These two are equal. They have 1 equation, 2 unknowns. Like, it doesn't freaking work. Like, in the general case, you have n equations n plus 1. N unknowns n plus 1. Or n plus n plus 1. It's actually so annoying. equation, 2 equation. This is it's like linearly dependent. Like you can't just set x1 to, if you set x1 you can figure out x2. That's true. And then you can figure this number out. And then you can figure out this number out. And then you can figure out, and this, you can figure out this number out. And you can figure out this number out. And so once you have this number. See, this is constrained by two things. Saying, like, you have, I don't know, guys, I don't know, and gonna go to bed, and then we'll see. This is very disappointing. It's like the problem C is like, it's like a big hurdle for me. Let's see how hard this problem is. I feel like it's 1500. You see, I can't even do a freaking 1400. It's so embarrassing. I can't figure it out. Okay, so I am cheating by looking at 2 pointers. So you have actually, so you m plus m plus 1, but you have m plus m equations, but it's actually linear independent, so you actually have an infinite amount of solutions. Therefore, if you set your first to 0, and have the sum, and you can figure out the second one row-wise, and then this is column-wise, and then if it goes down, you just make sure that this respects the sum of the column. So this is good, this is good. And this, the row respects the sum. And then this respects the sum. Like, this could be any arbitrary number. Like, I'm just worried, like, this won't be equal to this. That's very real. It may very well happen that the left side is not equal to this side. So how do we make sure like this is respected? Whoa. Did I just know that? Then this is equal to this. Then this is equal to this. Whoa. How did I not notice that? This should be equal to this, this, and this combined. Right? And this. So if it goes like and then if the corner is this, this should be equal to this. Like I tried it algebraically, now I'm trying it just like graphically. This. If only sum to 0. For this specific case, it works. But in general case, it doesn't. Wait, does it just work? Anyway, just make it so the 0 works. If you make the target 0, really, you can just. I was convinced it would not work. Dude, what am I doing? You're so stupid. Okay. We need to set the first one. What am I doing? What am I doing? What am I doing? What are you doing? What are you doing? You're going down. You sum over the column. This doesn't also work. Why are you so stupid, man? You basically need to know like where the next one is. So I was actually right. If you're moving to the right, that means that everything here, this section is clear. You're going to the right. Let's go down. We'll go down. If you're about to go to the right, you sum over the column. You go down, then it's like you need to sum over these. If you're about to go right, then you sum over the column. You're here, you're about to go down. You sum over the row. I was convinced it doesn't work, but maybe it does. It's like a property of the actual like, I mean, I said it like from the beginning, but it was not. Why does it work? I'm so confused. It was just like make it sum to 0, but then how do you prove that it? I guess the observation was that it's like linearly dependent, or like there's, if you write down like the system of linear equations, like how would you write it if x1 plus x2 is equal to x2 plus x3? Like really, you only have x1, and like all of these equations are equal. And I guess you row reduce it, and then it's always, there's an infinite amount of solutions. I'm so confused. Why does it work if it's just 0? Like I could have figured out algebraically. Yeah, I'm not convinced. I was like, you just set these to 0. Like, how can you guarantee that this is the same? How can you guarantee this equals target? Like, it's just not obvious to prove it. Like it was like, I instantly had the idea of like it being summing it to 0, but I was not convinced that it would work. So therefore I was like, let me prove it, which I think was fine, but I just don't know how I was able, how you can prove it. So we're just gonna go to the tutorial. Yeah, so this is the proof that I wasn't convinced. CP, zippy, interesting. Math for the grid that's summing. Two zero five five. Okay, so where is that proof? Oh, I kind of see it. So you know, like, okay, so then this sums to 0, this sums to 0, this sums to 0, and now you just made, or like, you knew this sums to 0, because you didn't know this, and then you made, it was going to the right, so you knew everything here. Actually, went down, and this sums to 0, and then this sums to 0, and you're going down, and then this sums to 0, you're going down, so you're going right, so this sums to 0. So this is your grid, and then you're going right here. This sums to 0. When you were going here, you couldn't go to the right, so you sum to 0. You're going down, so you can't do this. So you have to do this sums to 0. So now you know. So you have this, you know, this. And so you can do this, and you did this. This. So now through this process of exploration, you essentially did, when you get to the last node, like element, you basically checked all of the rows and columns. You have to, right, at some point, except this very last one. So these sum to 0, this sums 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 to 0. So like these numbers are not 0, but the sum is to 0. No, so this Alright, okay. If you make this like if you sum over rows versus summing over columns, it's gonna be the same result, right? You should have the same result. So if you sum it over the rows, then now you know all the sum over the rows is all 0. Therefore, you can conclude because the sum of all columns is 0 except the last one, it must sum to 0. So therefore, you've created a value such as the sum over the row is 0. You insert a value and now the row is 0. And then now if you sum over the columns, this value that you inserted must be 0 such that the sum is 0, because assume by contradiction that if you sum over the column it's not 0 and you sum over the column is 0, then that's impossible, right? Such that the sum over this row is 0. Sum over the entire matrix or the table, entire grid is 0. So if you look at the last, these are 0, so it must be inside this vector. This vector should sum to 0 as well. So without even looking at the vector itself, you know that it must sum to 0 after inserting this value. So then that's good enough, because if you put it, you know that all the other columns sum to 0. So this one was also sum to 0. If it doesn't sum to 0, that's a contradiction because all your rows sum to 0. Okay, that logic is kind of okay. Okay, got it. Alright, this was an interesting problem though. I think I learned a lot, and I spent way too much time, I guess, on this problem. Took me, I kind of guessed the answer, but the proof, I kind of understand it now. And it makes a lot of sense. So it took me like an hour for the second problem, when, you know, I got the idea like within 10-20 minutes. But it doesn't matter if you get the idea, you need to actually prove it. So yeah, okay. All right, we're gonna do some more Codeforce practice soon. All right, have a good night.